This is Geometry A, Unit 1, representing transformations in a plane. These are the guided notes from the lesson. I'm going to review some of the things in it. So if we look at this yellow box here, it says each point x, y, and the pre-image moves to point x1, y1, or x plus a, y plus b in the image. So it doesn't actually give us an image for this first problem here, but I will try to draw it for you. So we have polygon ABCD is translated to create polygon A prime, B prime, C prime, D prime. Point A is located at 1, 5. And A prime is located at -2, 1. And they want to know what the distance is from B to B prime. So if you're moving from 1, 5 to -2, 1, I'm going to, so A is at 1, 5. I'm going to try to draw this. So over 1, up 5. Here's the original A, okay? And then the next A is at -2, 1. So -2, up 1, that's right here. Okay, so what is the distance between these 2 points? We're going to use the distance formula, which is written up here. So distance equals the square root, this formula right there, of x2 minus x1 squared plus y2 minus y1 squared. Okay, so point A is how many units to the left? Well, if we're starting at 1 and we're going left, 1, 2, 3, 4. Wait, the difference between 1 and -2 is 3. And how many units down? So we're going from 5 to 1. That's 4 units down. So we can use the distance formula. Basically, it's going to be the square root of x2 minus x1. So that's what we just did. So 3 squared plus y2 minus y1, or 4 squared. So 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So the distance between them is 5. So the distance between B and the new B is going to be 5 units because you're shifting the whole thing to the left and down. So all of the points are going to move the same distance from each other. Okay, so a reflection, there is a line right here, EF, and it goes through the middle of the drawing. It's kind of diagonal. As you can see, EF right here. And it says that the triangles are reflected across that line. So for point A here, it's reflected to the A prime up there. And EF is a perpendicular bisector of between the 2 points A and A prime. So see right here, this 90 degrees, it's cutting the A line in half, and it's cutting it in half at 90 degrees. Now we have a table. So the following table shows how the coordinates of a pre-image change after being reflected across a certain line. So if we're changing the y here is negative, that means we're reflecting it across the x-axis. So imagine like the x values are the same, but the y values are now negative. It's because we reflected it across the x-axis. Okay, so if we're looking at the next one and the x value is negative, that means we're reflecting it across the y-axis. I know that's going off the side, but if you reflect it across the y-axis, the x values will be negative. Okay, if we reflect it across the line what, y equals what, you're going to switch your x and your y values. So, okay, so if my point A is at, let's say, 2, 1, okay, and I switch my x and my y values, so my new point A would be at 1, 2, and my new point B would be at like right here, and C would be like right here. So the line is right there. So where y equals x is where you would switch your x and your y values. I find it helpful to draw these. Now we have another reflection, and we're switching our x and y values, but they're also becoming negative. So I'm thinking it's going to be a line y equals negative x like this. So our A would be down here and our B. So y equals negative x for that one. And then across the what would give us negative x and negative y. So across the origin, that's the point in the middle. So it would look like this, where we have negative x and negative y. And if it's helpful, you can think about like your quadrants and what the signs are for your quadrants. So here, x and y are both positive, x is negative, y is positive. Here, x and y are both negative, and here x is positive and y is negative. So that can be helpful to think about as well. Okay, so the diagram on the right shows polygon ABCD, which has vertices at A is at 1, 3, B is at 2, 3, C is at 2, 5, and D is at 1, 4. If it's reflected over the line y equals negative x, what will be the vertices? So y equals negative x is this line right here. And we're going to reflect this across. So A is now going to be like, if we're reflecting it this way, so A is at 1, 3. The new A is going to be at -3, -1. And then B is at 2, 3. So if I follow this down here and then I follow it this way, so that's going to be right here. So the new B is going to be at -3, -2. That's a -3. And then C is at 2, 5. So this is going to be -2 and it's going to be -5. So that's like over here. And then D is at 1, 4. So it'll be at -4, -1. So your new shape would be here. Okay, so rotations can be around a point and along like different degrees. So let's look at this down here. And these are all rotations about the origin. The origin is the point in the middle. Okay, so I'm going to zoom into the picture. I'm going to try to zoom into the picture. There we go. So let's find the original one. So here's triangle ABC, which is the original triangle. And the first rotation is counterclockwise, meaning it's going opposite of the direction a clock would go. And see, it's 90 degrees. So counterclockwise, 90 degrees about the origin to get us our new shape, ABC right here. So that's counterclockwise 90 degrees. If we were to go 180 degrees counterclockwise, 180 is a straight line. And from our original one, this would be 180 degrees around the origin. And then 270 degrees would be like 90, 180, 270. Okay, so 270 degrees around the origin would bring us to the bottom, the fourth quadrant. Oops, too far. Okay, so polygon ABCD is defined by these points. If the polygon rotates 90 degrees counterclockwise, what are the coordinates of C? So I'm going to draw this really fast. We have graph paper would be helpful. So A is at -5, 1. B is at -4, 3. C is at -2, 7. And D is at -1, 2. Okay. If the polygon rotates 90 degrees counterclockwise, so we're going into this quadrant, right? What are the coordinates of C? So the original coordinates of C are -2, 7. And we're basically going to be switching the X and the Y values. So instead of, like, if it's going to be at -7, -2. So 1, 2, 3, 4, 5, 6, 7, 1, 2. So this is going to be our new C. And the image would be like this, because we're basically turning it to the left and down. So the new coordinates of C, oh, sorry, I wrote them in the wrong place. -7, -2. Okay, so a dilation is when something stretches or gets bigger or smaller, like when they put those drops in your eyes at the eye doctor. And it'll say how many times bigger or smaller it is with a scale factor. So if we look at this picture right here, we have our original triangle ABC, which is smaller than the new ABC triangle. And how much bigger and smaller is it? And this is dilated around the origin. So if we were to like take a measurement of the sides, it looks like it's 2 times bigger. That's not scientific, I'm just guessing. Because I don't know the exact point, so I can't tell. But it does look like these right here are equal distance, and these right here are equal distance. So I'm going to say that this triangle is dilated 2 times as big as this triangle. If I had the exact points for A, B, and C, I could like actually measure the distance, like the side lengths with the distance formula, and I'm guessing it would be 2 times bigger. Okay, so here's an example. Polygon ABCD is dilated about the origin. To create the new polygon ABCD, point A is located at 1, 3, and the new point A is at 4, 12. So what kind of dilation was used to create the polygon, and what is the scale factor? So if we have from the origin 1, 1, 2, 3, like here's the original point A, and the new point A is at 4, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's the new point A. Pretend that's a straight line. So how much bigger is it? It looks like we multiplied it by 4. So from 1 to 4 is times 4, and from 3 to 12 is times 4. So this is an enlargement, and the scale factor is 4, because all we did was multiply the original point by 4. So the 0.13 times 4 is now 412. Okay, so horizontal and vertical stretches. So here it's like dilating, but staying on the same, like just moving it up and then stretching it. So let's look at this one a little closer. A is moving from 1 to 2. C is moving from, I don't know, 0.4 to 0.8 maybe. And B is moving from 2 to 4. So it appears that it's being stretched upwards. And if we look right here, a horizontal stretch is where the X value is going to change. So horizontal is left and right. And a vertical stretch is where the Y value is going to change. So in this example, we have a vertical stretch because only the Y value is changing. So what are we multiplying our numbers by? If A is at 1, 1, and our new A is at 1, 2, we're multiplying the Y value by 2. And here we have B is at, I can't tell, something 2. I'm just going to put x2. And here we have B is at x4. We're multiplying the Y value by 2. So here in this picture with the triangles, we have a vertical stretch of 2. So that is it for this lesson. Hope to see you in the next class. Feel free to reach out to me in the meantime if you have any questions.